What did Kepler's laws reveal about early gravity theory? Imagine trying to understand how planets dance around the sun without knowing what pulls them in. Kepler's laws gave us clues about these cosmic moves, even before we knew about gravity. Kepler studied detailed observations of planets like Mars and Jupiter. From these, he created 3 rules that describe how planets orbit the sun. First, he found that planets move in oval-shaped paths called ellipses, not perfect circles. This was a big surprise because many thought orbits were perfectly round. Second, he discovered that a line connecting a planet and the sun sweeps out equal areas in equal times. This means planets speed up when they are closer to the sun and slow down when they are farther away. Third, Kepler showed that the time a planet takes to orbit the sun relates to the size of its orbit. Specifically, the square of the orbital period is proportional to the cube of the semi-major axis, which is half the longest diameter of the ellipse. These laws pointed to a force acting on planets that pulls them toward the sun, but Kepler did not know what that force was. He believed it was some kind of push or influence, not a pull. His work suggested that this force must weaken as distance increases, but he could not define its exact nature. Later, Isaac Newton used calculus to explain these patterns. He proposed that a force called gravity pulls objects toward each other. Newton showed that this force follows an inverse square law, meaning it gets weaker with the square of the distance. His law explained why planets follow elliptical paths and how the force depends on their masses and distances. Kepler's laws were a major step in understanding gravity because they turned observations into mathematical rules. They shifted science from just describing planets' paths to explaining the physical forces behind their motion. This change laid the foundation for modern physics and space exploration. Today, Kepler's laws help us calculate spacecraft routes, predict planetary positions, and understand the universe's structure. They remain as a key part of how we study cosmic and Earth science, showing us how the universe follows precise, predictable rules.